Hi everyone, I am Anil Kumar, a passionate educator dedicated to helping students develop a deep understanding of mathematics. Today, we are going to challenge a widely accepted idea. Is multiplication just repeated addition? Many believe so, but I will show you why this traditional view is limiting and misleading. Multiplication is not just repeated addition. Here is a new perspective. We have all been taught that multiplication is just repeated addition. But what if I told you that is not the full picture? Hmm. Today, I'm going to show you a new way to think about multiplication that will completely change how you see math. Change from algebra to engineering and spatial concepts. Let's uncover the deeper meaning of multiplication. This is just the beginning. Videos and articles will follow to help visualize this great concept in even more details. Hi everyone, I am Anil Kumar, and today we are going to challenge a common belief in mathematics. By the end of this lesson, you will learn why multiplication is more than just repeated addition. A two dimensional perspective on multiplication, how this applies to algebra, engineering, and science, and way beyond. Stick around to witness the breakthrough. Discover why multiplication is about structure, scaling, and relationships far beyond repeated addition. We'll begin with a general statement, which is 3 plus 3 plus 3 plus 3 equals to 12. Most textbooks teach multiplication as repeated addition, right? So say, well, you could say 3 plus 3 plus 3 plus 3 equals to 12 as 3 times 4 is equal to 12. Both are the same statements. However, here is a huge difference which makes all what we are talking about. Great. So, let's look into it in a fresh way. Imagine a ray. So, when we say 3 plus 3 plus 3, on one side of the line, we put these threes in groups. So, here we have four groups of threes. So, this is the first group, next group, third group, and the fourth group, and makes it 12. And that is how we see repeated addition on a number line. Perfect. But when I say 3 times 4 is 12, then what do we really see? We do get the same number 12, but does it mean the same thing? Have a look at it. Are the two results same? So here is how it is represented. Repeated addition moves forward in a straight line, as we just saw, placing the groups of threes, four of them, makes it 12 along a line. It's kind of a linear movement in one direction. However, when we talk about 3 times 4 in multiplication, it is rows times columns. What you notice here is again those 12 items, but what they are forming an area. You see the whole concept. It is a two dimensional vision. It is a transformation from single dimension to two dimension. That is what we are talking about, right? So in multiplication, 3 times 4 cover an area, though the result is the same as repeated addition. So at this closer look, what do you infer, right? Just as we expand from lines to spaces, multiplication goes beyond simple counting. And that's how we apply multiplication in mathematics, not just by representing it as repeated addition. So, what we have come here to is a paradigm shift in our thought from single dimension to double dimension, two dimensions. So, this shift from single dimensions to two dimensional is a kind of transformation, right? Perfect. So, multiplication is structured two dimensional transformation, not just linear addition. Makes sense, right? So, and here is the look how it changes our vision, our thinking. Multiplication enlightens an area, it forms a solid base for future, creating structure and expansion. That is, in true sense, multiplication. Engraving limited concepts have confined our vision so far. It's time to break free and rethink multiplication. You get the whole idea. I hope you like this concept. And now, once we think multiplication as not just repeated addition, we can now explain everything around us in a more beautiful way. And that is what I'm going to do in videos to come. And here, three examples I'm going to take. I'm dividing them into sections, into three different fields. And then we can actually go anywhere once we understand the correct meaning of multiplication, right? So here we came across a major issue, which is a dimensional conflict. So what we saw is addition is single dimension moving along a straight line. Multiplication, on the other hand, is two dimensional, covering an area. We know that repeated addition is a linear representation while multiplication is two dimensional representation of the same number, right? But they are not the same thing. They have different units. That makes all the difference we're talking about. This saying repeated addition is multiplication contradicts our science. This directly contradicts physics and science concepts. A single dimensional item cannot be equal to two dimensional quantities. Makes sense, right? Perfect. So, this is fundamental. It supports my concept that multiplication is not repeated addition. Let's explore this further through basic science. So, that comes to a very interesting part to apply this concept in different scenarios, right? Unlimited scenarios. So, here we'll consider basics. So, in the first video, I'm really considering very basic items. So, we had been working with mass and weight, and in science, we know how different they are. Now, this is where I'm linking the two things, points along a line with the area covered. Repeated addition, which is points along the line. Okay, great. So, let's rethink about repeated addition and multiplication and connect with mass and weight, right? So, consider mass m and the weight mg. So that weight is mass times acceleration due to gravity. So mass is like a point on the ray matter contained in the body. You can add it. Weight is a force, provides momentum and changes the dynamics. That's what our new definition of multiplication has done. That's where it is so important and critical in thinking. Multiplication introduces a transformation that alters physical interactions. Clear? Multiplication in science is not repeated addition, it's a fundamental transformation. You get the idea. So we move from single dimension to two dimensions, and now we're looking into multiplication as a transformation. See, a shift in our thinking, revolutionary shift in our thinking, unlocking the beauty of multiplication, right? Now, here we'll see how this correct thinking really is giving us correct results, right? So, here we're looking into space, the geometrical scaling factors all around, right? So, and we'll see how this concept of multiplication supports the transformation in spaces. So let's take example of length of a river and an area on a map. Scaling a 10-kilometer river on a 1 to 1000 map reduces its length. Perfect. It's a scaling factor where the multiplication is there. Scaling 100-kilometer square region on the same 1 is 2000 map reduces the area. But that is two-dimensional change, right? So thinking multiplication as what we are saying brings all the things together. It is not repeated addition. It was never repeated addition, but a wrong perspective, which we are changing with this particular video. So I hope this concept is clear. Once again, multiplication is beyond repeated addition. It helps us to explain above transformations and its wide applications in many other applications which we are going to explore. This is not just repeated addition, it's a transformation of space. Makes sense, right? So, with that, we come to the end of this video, and now here are some thoughts. We explored multiplication beyond repeated addition, perfect, and that helped us to understand many phenomena in different areas: algebra, science and technology, and geometric scaling. So, this concept of multiplication forms a basic vision of an area. So, it's not one dimensional, it is two dimensional. With that, we can actually explain many concepts in real life. So, the key takeaway is multiplication is not just repeated addition, it's a powerful mathematical tool that helps us understand growth, scaling, and real world problems, right? Which can be solved easily with this particular concept. I hope it makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for sharing. All the best. Have a great day.